Imagine a world ruled by reptiles. A time when the land was dominated by dinosaurs, but the oceans were the domain of something even more fearsome. Not just any reptiles, but colossal, sea-dwelling behemoths that patrolled the oceans with unmatched power and grace. These were the mosasaurs, the apex predators of the Late Cretaceous period, ruling the seas with an iron fin. For millions of years they reigned supreme, their dominance unchallenged by any other marine creature. These weren't dinosaurs. They were more closely related to snakes and lizards, sharing a common ancestry that dates back millions of years. But their size? Think gigantic. These creatures were among the largest marine predators to have ever existed. Some reached lengths rivaling a school bus, stretching up to 50 feet or more. Mosasaurs looked like a fearsome mix of a Komodo dragon and a shark, with a long, streamlined body built for speed and power. They had powerful tails for swimming and flippers to navigate the water. Their jaws were massive, capable of delivering a crushing bite. Inside, rows of sharp conical teeth were perfect for grabbing and crushing prey, making them efficient hunters. Fish, ammonites, even other marine reptiles weren't safe from their relentless pursuit. Mosasaurs were the undisputed kings of their domain, ruling the ancient oceans with a fearsome presence that left an indelible mark on the history of marine life. The world of paleontology is always full of surprises. Just when we think we understand prehistoric life, a new discovery turns everything upside down. Enter the Dagger-Toothed Mosasaur. This isn't just another mosasaur. This one's different. This one's special. Scientists recently unveiled this new species. Its scientific name is... It's a mouthful, right? But the name's not the most exciting part. The teeth are what have scientists buzzing. Forget the typical conical teeth of other mosasaurs. This predator sported something much more sinister. Imagine a mouth full of razor-sharp daggers. That's what the Dagger-Toothed Mosasaur possessed. Its teeth were long, slender and curved, like the blade of a scimitar. But here's the kicker, they were serrated. Jagged edges lined each tooth, like a steak knife designed for tearing through flesh. These weren't teeth meant for crushing bones. No, these were specialized tools for slicing and dicing. The Dagger-Toothed Mosasaur was built for a very particular kind of hunting. It targeted soft-bodied prey, delivering swift, deadly slashes that would have ripped through flesh and muscle with ease. Our story takes us to the phosphate mines of Morocco. These mines are a treasure trove for paleontologists. They offer a glimpse into a time when dinosaurs roamed the earth. It was here, amongst the ancient rocks, that the first traces of the Dagger-Toothed Mosasaur were discovered. The fossils were embedded in marine rock formations dating back to the Late Cretaceous. This was a time when Morocco was submerged beneath a vast, shallow sea. The discovery was remarkable. It added a new piece to the puzzle of mosasaur evolution, but it also raised more questions than answers. Section 5, Evolutionary Puzzle, Challenging Mosasaur Norms. The discovery of the Dagger-Toothed Mosasaur has sent ripples through the paleontological community. Why? Because it challenges what we thought we knew about mosasaurs. Here was a creature that broke the mold. It didn't conform to the typical mosasaur blueprint. Previously, scientists believed that mosasaurs were largely ambush predators. They relied on their powerful jaws and crushing teeth to subdue their prey. But the Dagger-Toothed Mosasaur tells a different story. This was a hunter that engaged in a very different kind of warfare. It was a specialist, adapted to exploit a specific niche in the prehistoric ecosystem. Section 6, Slashing Through the Depths, a unique hunting strategy. Picture this, the murky depths of the Late Cretaceous ocean, visibility is low. Suddenly, a shape emerges from the gloom. It's the Dagger-Toothed Mosasaur, and it's on the hunt. But unlike its bulkier cousins, this mosasaur doesn't rely on brute force. It uses speed and agility. It darts through the water, its slender body cutting through the currents. It spots its prey, a large squid, its tentacles trailing behind it. The mosasaur strikes with lightning speed, its jaws open wide, revealing those terrifying dagger-like teeth. A swift slash, and the squid is mortally wounded. The mosasaur has claimed another victim. Section 7. Echoes in the Present, Mosasaur versus Modern Predator. The Dagger-Toothed Mosasaur might be long gone, but its hunting style has echoes in the modern world. This ancient marine reptile, which ruled the oceans during the Late Cretaceous period, was a formidable predator. Its powerful jaws and sharp, serrated teeth made it a master of ambush, capable of taking down prey with swift, lethal strikes. Take the great white shark for example. This apex predator of today's oceans shares many characteristics with the Mosasaur. Its sleek, torpedo-shaped body allows it to move with incredible speed and agility, making it a fearsome hunter. Its teeth are also serrated, designed for tearing through flesh. These razor-sharp teeth are perfectly adapted for gripping and slicing through the tough hides of seals and other marine animals, much like the Mosasaur's teeth were suited for its prey. Or consider the Komodo dragon, whose bite delivers a potent cocktail of venom and bacteria, weakening its prey. The similarities are striking. This terrestrial predator uses a combination of stealth, power, and a deadly bite to subdue its victims, echoing the Mosasaur's hunting techniques in a different environment. They highlight the power of convergent evolution. Despite being separated by millions of years and vastly different habitats, these predators have developed similar adaptations to thrive as top hunters in their respective domains. This is the process by which unrelated organisms evolve similar traits in response to similar environmental pressures. It's a testament to the efficiency of certain evolutionary strategies that these traits have emerged independently in such diverse creatures. The dagger-toothed mosasaur, the great white shark, and the Komodo dragon might be separated by millions of years of evolution, but their shared hunting strategies speak to the timeless efficiency of nature's designs. These predators, each a master of their own domain, remind us of the incredible adaptability and resilience of life on Earth. Section 8. Mosasaur Marvels Fun Facts from the Deep. Ready for some amazing mosasaur trivia? These ancient reptiles were full of surprises. Did you know that some mosasaurs had double-hinged jaws? That's right, they could open their mouths incredibly wide, swallowing prey whole. And remember how we mentioned that they weren't dinosaurs? It's true. Mosasaurs were actually more closely related to snakes and monitor lizards. And here's another mind-blowing fact. Mosasaurs gave birth to live young. They didn't lay eggs like most reptiles. Instead, their babies were born ready to swim in the open ocean. Pretty cool, huh? Mosasaurs might be extinct, but they continue to fascinate and inspire us with their incredible adaptations and remarkable lives. Section 9. A Shadow of Doubt. Forgery, or a groundbreaking find. The discovery of the dagger-toothed mosasaur has generated incredible excitement. This find has the potential to change our understanding of prehistoric marine life, offering new insights into the diversity and evolution of these ancient creatures. The initial reactions from the scientific community were overwhelmingly positive, with many hailing it as one of the most significant paleontological discoveries of the decade. But there have also been whispers of doubt. As with any groundbreaking discovery, skepticism is a natural part of the scientific process. Questions began to arise almost as soon as the initial excitement settled. Some experts have raised concerns about the authenticity of the fossil. These concerns are not to be taken lightly, as the field of paleontology has seen its fair share of forgeries and misidentifications in the past. The stakes are high both for the credibility of the researchers involved and for our understanding of the fossil record. Could this incredible creature be too good to be true? The very features that make the dagger-toothed mosasaur so fascinating are also the ones that have drawn the most scrutiny. The skepticism stems from a few unusual features in the fossil. These anomalies have led some to question whether the fossil might have been altered or even fabricated. The arrangement of the teeth, which seems almost too perfect, has particularly raised eyebrows. In nature, such perfect preservation is rare, leading some to suspect that the teeth might have been rearranged to create a more impressive specimen. The source of the fossil, from a region known for manipulated specimens, has only added to the controversy. This area has a history of producing fossils that have later been found to be tampered with, making any new discovery from there subject to intense scrutiny, and the lack of clear provenance have fueled suspicions. Without a well-documented history of the fossil's discovery and handling, it's difficult to verify its authenticity. Some fear it might be a clever forgery, designed to cash in on the lucrative fossil market. The financial incentives for creating and selling fake fossils are significant, and this has led to a number of high-profile cases of fossil fraud in recent years. To quell these doubts, scientists are calling for further investigation. Rigorous testing and peer review are essential to establish the fossil's authenticity beyond any reasonable doubt. CT scans and detailed analysis of the fossil's composition are crucial. These advanced techniques can reveal whether the fossil has been tampered with, or if it truly represents a new species. If proven real, the dagger-toothed mosasaur will rewrite our understanding of mosasaur evolution. It could provide new insights into the diversity of life in prehistoric oceans and the evolutionary pathways of marine reptiles. However, if it turns out to be a fake, it will serve as a stark reminder of the importance of rigorous scientific scrutiny, even in the face of the most captivating discoveries. The scientific community must remain vigilant to ensure that our understanding of the past is based on genuine evidence.